Good afternoon, everyone. Thank you for joining us today. I'm Sherilyn Burton. I'm with the California Department of Fish and Wildlife's Native Plant Program in the Habitat Conservation Planning Branch. Today's lecture is part of our Conservation Lecture Series. So you can view the schedule for the Conservation Lecture Series and register for upcoming lectures and watch videos from past lectures on our website. And there's the link there, and that's what the page looks like, and you can subscribe for updates as well. So we have one lecture scheduled for now in September. We have Dr. Frederica Bocut. She'll be talking on the tan oak and an environmental history of that tree. Also, before I introduce our speakers, I'd like to ask you to hold your questions until the end of the talk. That way I can walk around with the microphone so people on the WebEx can hear. And if you're on WebEx, type your question into the chat box, and then I will read the question to the presenter at the end of the talk. So today we have a joint presentation by Heath Bartosh and Brian Peterson. Heath Bartosh is the senior botanist and rare plant specialist at Nomad Ecology in Martinez, California. One of his primary research interests is the composition and duration of the eruptive dominance and subsequent fleeting abundance of post-fire annual plant species at regional scales within the California coast ranges. Having studied fires on the Monterey coast and Diablo Range, it's only one, he focuses on plant distribution, soil and geologic relationships, endemism, and regional and local rarity of these fire-following plant species. Our other speaker is Brian Peterson. He is a botanist, fire ecologist, and GIS specialist, also at Nomad Ecology. Since 1997, Brian has worked in Southern Oregon and Northern California in fuels reduction, oak restoration, and as a botanist. Brian earned an MS in Ecology, Evolution, and Conservation Biology from San Francisco State University, where he studied manzanita ecology with Tom Parker. Brian's master's thesis research investigated the relationship between seed-caching rodents, manzanita, and fire. Brian is focused on using his skills and experience to facilitate ecologically informed land management practices. So thank you both for coming today, and I will turn it over to Heath.
Thank you very much, Sherilyn. It's great to be here. It was probably about a month after the Morgan fire kicked off in Contra Costa County, and Brian and I were working down in Monterey, actually in the former footprint of the Basin Complex fire down in Big Sur. And, having both an interest in fire following plant species and fire ecology, we thought, gosh, wouldn't it be great if we could get onto Mount Diablo with some support from state parks and do a little post-fire study. So we got in touch with the contacts at state parks, California state parks, and they gave us some funding support to do a 3-year study. So at this point, just in terms of where we are at overall, we've just completed our 3rd year of sampling. So it's done now, and we're going to this fall and winter move into the data analysis, final data analysis phase. But the talk really is sort of structured around just fire ecology in general, fire following plants, how our study was designed and implemented, and then some data analysis from the first 2 years with a little bit of prediction for what we might find when we analyze the data and for the 3rd year. So Brian and I, we are going to kick off back and forth from slide to slide, and it's going to be a dynamic duo effect up here.
So really quick, oh wait, I should talk into the microphone, huh? Is that good? Okay, so real quick, I'm sure a lot of you, working in California are really familiar with how important fire is in California, but it's a pretty ubiquitous process throughout the whole state because due to our Mediterranean climate, for the most part, our dry summers and wet winters. But one thing we're really interested in is kind of chaparral and post-fire species of chaparral. So I think it's important to, though there's fire all across the state, it doesn't necessarily operate the same in every ecosystem. So there's a lot of different kind of things going on throughout the state as we investigate these fire processes. One way. Oh, yeah. Oh, sorry. The red right here is all the fires that have happened since the turn of the century in California, from the CAL FIRE database. And so that gives an idea of where, obviously in the desert areas, we don't get as many fires, but you see all throughout the state, there's a lot of fire burning. And just to give you a little brief idea about what fire ecologists think about, especially plant fire ecologists, is we think about fuel structure. So that's how the fuel is structured across the landscape. So that's whether it's grass or shrubs or trees, and that's vertical, but horizontal too. Is there a lot of meadows and forests kind of patchy, or is it one big forest that all has the same exact kind of spacing with the tree, and is that dense and stuff? So the fuel structure really drives how fires burn, how often they burn, and how severe they are when they burn. So another thing we think about is fire return interval. That's how quick fire comes back to the landscape. So that's how often it burns. So often grasslands will burn many times in say like every 5 to 10 to 15 years, whereas chaparral might burn every 80 years. And that really also kind of, the vegetation, it's kind of a feedback as vegetation creates that fire interval, but also fire interval can kind of maintain or create vegetation types. We think about fire severity, and that's, basically how hot a fire is and its effects on the soil and the vegetation above ground. And we also think about, we kind of take it down to the species level and think about individual species as well and their life histories, strategies. So whether they come up after fire from the roots, whether they resist fire with thick bark, or whether they hide out in the soil seed bank. So there's all these different ways in which plants are dealing with this chronic fire on the landscape. And then we think about species. We kind of go up from species, individual species, and go up to species assemblages. And we think about how is fire shaping these assemblages, these different, many species that are growing together kind of in patterns across the landscape. So that's just some basic fire ecology stuff. Also, we just want to, and sorry if some of your favorite botanists or fire ecologists aren't on the slide, there's so many of them, but we just wanted to say that this has been something that's been really post-fire flora and fire ecology in California. It's something that people have been interested in for a long time in California, botanists, and more recently, fire ecologists have actually has become a word, fire ecology. In the past, I think a lot of botanists were just interested in the plants coming up after a fire. But yeah, so we just want to give a shout out to all the shoulders, that we're resting on doing this work.
And I'll go back here for just a second, just to point out Mary Bowerman, who wrote the flora of Mount Diablo, and she actually, when she wrote the flora, when she did her field work for the flora, that was during the 1930s fire on Mount Diablo, and so she actually had a good record and kind of a blueprint for what we would see after the Morgan fire in 2013. And as things unfolded year after year, it was pretty similar to what Mary had recorded in her flora. So hats off to her. She did a lot of hiking around the mountain in the 30s, coming all the way from Berkeley on a dirt road. So pretty tough lady. Just the next couple slides, kind of just to point out this idea of regional fire followers and what we know about them and what we don't know. So there's a mallow, Iliamna bakeri, that grows up in the northwest portion of California, and some of the information that's included in the Jepson manual, or the descriptions and the treatments of these species, misses out on whether or not they're influenced by fire. Sometimes in the Jepson manual or other, in the descriptions of these species, there'll be information that says follows fire or enhanced by burns, and species like this don't necessarily have those. So the habitat info is incomplete. We don't really know what their germination triggers are. And so their life history is less well known, and how fire severity affects a species like this isn't really well known either. And speaking with some botanists up in Northern California, like Julie Evans, a species like Iliamna comes onto the landscape after fire in a big way. And did I say Evans? I meant Julie Nelson. Evans is right there. So it's trying to piece together information like this to help round out the the idea of what we're dealing with on a regional fire following level. A couple years ago, actually the same year in 2013, Brian and I were also working up in the rimfire area, and were able to revisit that burn for 2 subsequent years after 2013. And one of the species there that we saw a dramatic response, positive fire response, was this species of Clarkia, Mariposa Clarkia. And it's known to have a Sierran distribution, but it doesn't really say either that it's a fire follower, and so that's information that's incomplete. It can occur over time after a burn. After a burn, you have the species of Clarkia coming up in bare areas, and as the vegetation grows back, it will persist on the landscape. So it'll go from being an open habitat to shaded habitat where there's seedlings and saplings, and then it'll sort of cling on to these forest types as the trees get taller and older. But when you see it in that one space and time, you think, oh well, it's a forest understory dweller, and don't really realize that it was way more abundant when the forest had just been burned.
So this is just a real quick preliminary thing we did, where all these. So first off, the brown, that's all Chaparral in California, and then the yellow diamonds represent studies that really take kind of plot data of herbaceous species in a fire environment. And one thing you'll notice is that they're very much clustered down in Southern California, and that's because post-fire following plants and fires down in Southern California, and so much Southern California chaparral. That's where most of the research has been done. But there hasn't been a ton in Northern California, official studies that collect plot data. Like I said, it's just preliminary. We didn't do as full of a lit review or contact as many people as we could have, but it just gets a basic idea. I'm just doing a database search, Web of Science. And so I think it illustrates that there's plenty of chaparral in Northern California, and it operates differently than Southern California, most likely. And there's different species involved, and so it really needs more research to understand how these things are going. And we're going to have different issues in Northern California than Southern California as far as healthy chaparral.
So just a few brief facts on Chaparral and Fire. This is actually a picture of Mount Diablo, looking from Eagle Peak back towards the summit. And you can see tons of chaparral there. And so that's really our primary research interest, is how chaparral in Central and Northern California operate post-fire environment. But just to take a few facts from our friends at the Chaparral Institute down in Southern California. Chaparral is large, low-frequency fires. That's typical. So that's something that we're used to, and taking that and applying it to Mount Diablo, there's been a fire return interval of about 40 years. So it's been large fires, and the age of the and density of the chaparral has little to do with the occurrence of large fires. So chaparral doesn't have a bunch of fuel loading like you'd imagine in a forest environment where ladder fuels build up and surface fuels build up. Usually what you're left with after years of chaparral growth is just small leaves that drop off the shrub and eventually decompose into the soil. And the fire regime of chaparral is a crown fire, so it comes through and it just burns the entire crown, leaves nothing below, and except for this ashen moonscape. And it's a little tough to see in the picture. I'll show some others later, but you'll see what this ashen moonscape looks like. And the natural fire return interval for chaparral can be between 30 and 125 years. And so, based on what we know of Mount Diablo, we've been lucky enough that we have records from Mary Bowerman in the 30s. There was a fire there in the 70s, and then the fire in 2013. So it's been pretty regular, 40 years of fire return interval. And those, I believe are predominantly human started, so not necessarily natural. But the other thing is that we know a lot about post-fire on Mount Diablo, at least from species-wise, from Mary's work. And being in the Bay Area, there's tons of botanists there that love to get out in post-burn areas too. So the other thing where fire return interval is a negative is if it happens in chaparral sooner than 20 years. So if your fire return interval is more frequent, then you could end up with type converting chaparral to grasslands and weedlands. So this is a picture on the south side of Mount Diablo. So on the upper left, you can see there's chaparral and black sage, and in the bottom right, you can see the chamise is gone, the black sage is gone, and you get that ashen moonscape look. And right after a fire, and you know, it was so evident being up on the mountain after the fire, everybody was like, "Oh, it's so devastating! I can't believe that, you know, the mountain's been just destroyed." And you know, the fire happens, and I think as a botanist, you kind of try and, you know, be reserved, like, yeah, it was terrible, but on the inside, you're kind of like jumping up and down because you know what's coming. So let's just take a minute to talk about life history strategies, at least within the chaparral environment, and focus on two manzanita species real quick. These are both, do I want to give control to Mari? Yeah. Do I? So anyway, we're looking at Contra Costa manzanita, which is the greener one on the left, and Mount Diablo manzanita, which is the grayish one on the bottom right. And these are both seeders. So manzanitas have two life history strategies, either resprouting or seeding. And so these two manzanitas, which happen to be endemics to Contra Costa County, just pump seed into the ground every year. So their strategy is basically we'll allow ourselves as adult plants to die off, and we'll you know, give the seed bank a chance at putting the next generation out there. I don't. Okay. Let's see. Oh. Uh-oh. There we go. Okay.
Just going to take this opportunity really quick to talk kind of about some my thesis work. But so as a seeder, you know, it's one of the most important things is the soil seed bank. And so as Heath was saying, the fire comes through, kills the mother plants, and then the germination, then the fire stimulates germination of all the babies that have been sitting, all the seeds that have been sitting in the soil seed bank for potentially a very long time, upwards of 80 years sometimes. Now, the one thing that's really important is to really realize is that sometimes we think that these seeds are fire tolerant, but they're not necessarily the case. They can die at pretty low temperatures. And what's really happening is that the soil is a very, very good insulator. So when I was doing my experiments, I had a fake oven and was heating the soil and stuff, and found that like about 5 centimeters down, when it was roughly 800 degrees Celsius, in the oven, about 5 centimeters down is around 75 degrees Celsius. So there's a huge, steep heat gradient going down. You can see in this graph over here, this was actually done in the field when chaparral was burnt. You can see the different temperatures profiles at the different depths in the soil. You see the surface is almost 700 degrees Celsius, and then down at 5 centimeters there, it's below 100. So it really illustrates how important the soil seed bank is in this whole process. And what I did research on is that these seed caching rodents would take the seeds and bury them in the soil, and that actually helps improve or speed up the process of getting seeds low enough in the soil to be safe from a fire. And so the idea basically is that there's a kill zone in the soil seed bank, and as rodents bury it, it gets kind of below that kill zone, so a larger probability of seeds are likely to survive. And it also distributes seeds in the soil seed bank so that it can deal with different kinds of environments, the different kinds of heating regimes. Does Marty have control? We did that, yeah. I think Marty has control. It's fine, just tell me what to do.
There we go.
Oh, I got it.
Okay, So, moving from seeders to sprouters, this is the other life history strategy that's common in chaparral environments, and we're talking about chamise here, which is a good example, even though, I mentioned that there's manzanitas that also resprout after a fire from a burl. But the strategy here is that you have this thing that's referred to as a lignotuber or a woody potato, something that stores energy over a long period of time and gets a little bulbous at the top near the surface, and you can see that bulb of the lignotuber there, or the burl, as it's often called, right there at the soil surface. And this picture was taken about a month or two after the fire, and you can see the little green sprouts at the bottom of the burl that are already coming out. So the response time after a fire for the resprouting to occur is pretty rapid. And so that's why it doesn't take that long for chaparral to recolonize the landscape or, retake dominance of the chaparral community there. It's the time in between that it takes over, and from when it's burned is when all these other annuals and short-lived perennial species occupy the landscape. And then the other thing is what we're talking about, or we'll talk about and looked at on Mount Diablo, is the idea of just obligate fire followers, plants that really just come up after a fire, and their germination triggers are really tied to either the heat or the chemical interactions of the post-fire environment, or other fire-related triggers. And then there's this other idea about native disturbed, and so species that they not necessarily are fire-following obligates, but that they appreciate the disturbance that the fire creates and take advantage of the open spaces in the chaparral. So here we've got this species Monolopia grasslands, which happens to be a rare plant that's distributed mostly in the coast ranges, south coast ranges, that comes up only after a fire. And then there's something like Media gracilis, where in both the Morgan fire on Diablo and the Basin Complex fire down in Big Sur, I saw sheets of it all over the place. That it wasn't necessarily fire followers, just taking advantage of the disturbance there.
So our real big interests are in this idea of fleeting abundance. And that's really just after the fire, these herbaceous, annuals or short-lived perennials come up right after the fire, occupy the space after the fire for 5-6 years, and then disappear as the chaparral takes back over. And really, like I said, a lot of botanists have paid attention to these plants. But most fire work that's vegetation in fire has been mostly done with like trees or shrubs and these kind of larger dynamics without much being paid attention to the herbaceous layer, which is probably true for a lot of California in general, but definitely with fire. And so we definitely want to focus in on that. And it's also kind of exceedingly difficult to study because you don't know when the fire is going to happen or where. And you only have a few years to really get it together, to get out there and put plots down and do a whole study design. So that's really what we're after. You can go out there quickly as a botanist just to visit for a day or something after a fire, but to get a whole research program going on in a matter of a few months is difficult. So that's really our interest, is understanding these plants, not only what plants are there, but also a little bit more about their dynamics, their different abundances, and the diversity in these systems. So I pretty much just talked about this slide in the previous slide. But another thing is, we're interested also in trying to, if we can get enough data in different fires, we might be able to begin to understand some of the environmental drivers that these species are under, not just the fire, but also are there soil types they like. And again, it's really hard to get that because we can't go out just any year and find a bunch of information on these species. We have a short time frame after a fire to find out about them. So we also are interested if fire severity has a certain effect on these species. Like I was saying about the seed bank, maybe some species have a relationship with ants or something, so their seeds are lower in the seed bank. So if there's a higher severity fire, they're the only ones left standing, and then they come up out of the seed bank. Oops, sorry. So there's a lot of potential interesting ecological relationships like that, and we're trying to use plot data to really get at it because it's really difficult to do otherwise. We also want to take have a better understanding of how like diversity of fire followers operates kind of on the regional scale all throughout California. So, is there more diversity in Northern California fire followers in Chaparral or Southern California, or are the species pretty similar to each other and those kind of dynamics? Also, we want to learn more about weed establishment and abundance, and so we can use this plot data and maybe things like how close it is to a fire line or to a road to kind of help predict what kind of weed establishment is going to happen. So really, we're focusing on the herbaceous layer, like I stated before, and we really want to capture diversity of different species. And we also really want to develop something that was simple. It was a simple sampling methodology while also getting a high amount of information on diversity. Like I said, it's really hard after a fire to get out there quick enough, and it's hard to find the money for it and all these things. So we really wanted to make it simple, quick, and to be able to apply in pretty much Northern California, Southern California, any post-fire environment. Just get in there and get this information. And we're also have been building. We've got a few projects going on. We built a database where we're attaching information to all the species that we find that is ecological information that's relevant. So really trying to get like maybe if there's any research on pollinators for these species, research on seed dispersal, anything we can find in the scientific literature, and really attach it to the plant in the database, and then we can organize species in different functional groups, and that will help us understand too if there's any interesting ecological dynamics of these plants.
So there's this idea that some people have that Mount Diablo is a volcano, and it's not really. It's not a dormant volcano, but pictures like that sure make you think otherwise. That picture was taken the night of the Morgan fire from Pleasant Hill, which is sort of northwest, looking back, and the gap between the two peaks is Prospector's Gap. So if you keep that in mind for the next couple slides, or Brian will point out some fire severity slides, you'll see what that looks like on a fire severity map. But for those of you who don't know, Mount Diablo is more or less the center of Contra Costa County, and it's illustrated by the red star there, so we're not too far away. If you haven't been, it's only an hour's drive, an awesome place to hike around and look at the flora. The elevation's almost 4,000 feet, so Diablo is really the head of the Diablo range, which continues on further south. But you can see it's this big convergence zone. So floristically, it's pretty interesting because you've got all these coastal influences from the Central Valley, the North Coast ranges, or the South Coast ranges. And then actually you also have some Sierra and disjuncts coming over and living over on the mountain from the foothills. And then just to give you an idea, sort of, you can see up there, that's really like the head of the Diablo range. And there's Mount Diablo, and it continues down. And the Diablo range actually goes down to Parkfield, which is about 150 miles to the south. So it's this whole body of separate ranges that make up the Diablo range itself. And floristically, they're pretty similar. Now, just a quick introduction to the floristics of the East Bay and Mount Diablo. If you think about California, we've got about 7,600, maybe some people say 8,000 species in California. In the East Bay, there's about 1,600, so you got about 22% of the California flora just in Alameda and Contra Costa counties, which is pretty remarkable. Then if you drill down to Mount Diablo and the species that were included in Mary Bowerman's second edition of her flora, you've got 841, so that's about 10% of the flora of California. So that's still pretty amazing. And Mount Diablo is also a place where you have range limits, where species from the south reach the northern end of their range and species from the north reach the southern end of their range. So it's really, I said melting pot, a convergence zone. It's a floristically very interesting. And just some quick statistics on the Morgan fires. September, when it was started from target shooting. Somebody was out there on a 100-degree day shooting their rifle. And it burned for about a week. And then the total area was about 3,000 acres, and it cost about $4.5 million to fight the numbers of people that fought the fire, they say, were about 1,000. But the interesting thing was, I think about 500 of those were convict crew individuals. So getting help from the Department of the Corrections there. Then here's a map showing the state park boundaries and the fire perimeter. So the star represents the peak of Mount Diablo, and so most of the fire perimeter burned within the state park, although there was some private land and then also some land held by a local land trust that we were lucky enough to get access onto also.
So this is a fire severity map of Mount Diablo. It's using the BARC data. And this data really uses infrared light to kind of understand how hot the fire was, or how much vegetation is left over, basically how much green is reflected back, and the red being the most, the highest severity, and the light blue being the lightest severity. Now, this is something that's used a lot, but I think it's really important to remember this is just a model, and so it's helpful, and it really works, I think, well in some forest environments, but. Again, it's just a model, and so it doesn't necessarily tell us exactly what's happening in the landscape, and I would argue that this is especially true for Chaparral. So here's a picture, a real live picture, and you can see where the white ash is. It's probably where it burned quite a bit hotter, and where it's a little bit darker, there's still some standing wood there. And so this is a picture even getting closer in. This is a chemise chaparral, and if you notice that, like over here to your left corner here, there's you can see almost no chemise sticks standing up, right, and not much sprouting back. On this other side, you can see that there's some sticks left over. And so really what that shows is that it was hotter over here, and it burnt all of the wood down. And over on the other side, it was a little less hot. And so what we really noticed while we were up there is even within the chaparral that looks like the quote-unquote moonscape, with on maybe a scale of 20 to 30 meters, sometimes there was these spots where there was super hot and there was nothing left over, and chemise wasn't even sprouting up very well. And right next door, there would be a bunch of sticks still there and a bunch of chemise sprouting rapidly. And so I think that fire severity can also, although it works at a large scale in Chaparral, it also is really working at a small scale. And then I want to remind you too, as we're thinking about this, if soil heating is so important in Chaparral, like I pointed out with some of my thesis research, that the species that come up over here as opposed to come over there might be different depending on where they are in the soil seed bank. So this can be a pretty big driver of diversity, and there can be a lot of diversity within the Chaparral. And also, if you go out in the post-fire environment, you will notice that there's like some fire-following species there, and then you'll notice some species that absolutely don't even like fire, but they'll be coming up, or they're not very resistant to it or something, and they'll be coming up like relatively what seems like the same stand or the same area, but that could be driven by these kind of really small-scale dynamics here. And I'll talk about the methodology, but we really tried to capture this in our methodology. So the real objectives of the study was to get abundance and distribution within 3 years after the fire. We wanted to capture that quick little burst of plants. We wanted to get the species and abundance as well. We wanted to kind of better understand variables affecting post-fire vegetation composition. So we really wanted to see if we could find any kind of signal with soils or slope or aspect, these kind of type of things, and fire severity, to see if we could kind of pick up if there's anything driving what species are growing there, or if it's just simply that's where the seeds were. We want to we want this study design to be able to get local level species responses, so we can understand also things at different regional scales and see if these things operate at different scales. We also want to find out about the post-fire weed drivers. So same as the post-fire following plants in general, we just want to kind of understand why things are growing where they're growing. And then we want to see if fire severity affects on plant diversity. And so for the study design, we're mostly interested in chaparral. We know that's where the most interesting fire-following plants are, but we also felt that we should really try to check out every vegetation type that burned on Mount Diablo, so that we can try to understand the dynamics between the different vegetation types in the post-fire environment. And so for this project in Diablo, we got 10 plots in chaparral, 9 in deciduous oak, 11 in live oak, and 10 in grassland 4. And then there's a little bit of serpentine that got burnt, so we got 5 plots in the serpentine chaparral and serpentine grassland in that area. And mostly we got 5 plots just because it was actually a pretty small area. And so we used a stratified random sampling design where we put random points in these different vegetation types. And that's a picture of all of our points and colored by vegetation type. And this is where I like to really show people that, or ask people to notice how tight those topo lines are, just to give us, all of the field people who collected this data, a little shout out. That's mostly me and Heath, but definitely other people were involved. So it's the study design. We used belt transects, and we used 50 meters long, and then we used 1 meter quads at every other meter. So that's 25 quads. And we collected percent cover data of every species that fell within those quads. We also recorded fire severity data at 2 scales. So we have the fire severity of what we're calling the plot, which is the 50 meter long transect, and that's kind of the general area. And then we got fire severity at every one of those quads the first year. And really, there are some ways to measure fire severity at a more finer scale in Chaparral, but it's pretty labor intensive. So really, we did a low, medium, high qualitative at every meter square. So really, over a 50 meter long section, we might have crossed a few different boundaries of that fire severity I was showing in that slide, where it was pretty high and then get kind of low. So we're going to try to use that data, though it won't be totally independent. I think it might be interesting for future research to kind of see if there is a big effect of that. And the reason that we use belt transects and percent cover data was, percent cover data, as we all know, does have problems as far as how it can be pretty variable between different people who are collecting it, and it's not super, super accurate. But other methods like point intercept really do not do a good job of capturing diversity, and that's really what we're mostly interested in. And we're also really interested in the relative abundance of these different species. So in that regard, that kind of helps ameliorate some of that, that error.
Right, so we're going to take a little tour through our first year of data and give you a summary. So just in terms of species richness, I had that slide up there that's 841 species on Mount Diablo, and just in the plots that we captured for the first year, we got 223 taxa there. So we chewed off a good chunk of what was out there on Mount Diablo. Then, I talked about the difference between what we are talking about, fire followers, obligate fire followers, and of those we got 17 taxa, and 14 of those are considered locally rare, and local rarity is something that's tracked in the East Bay through the local chapter of CNPS, the Native Plant Society, and so we actually were able to utilize their database to compare, which one of these fire followers are actually locally rare, so we can pull out a lot of rarity data there, that way. And then the native disturbed species, which are the ones that are just taking advantage of the fire disturbance, the open space out there on the landscape, we had 28, and those were species in the Jepson manual that said likes disturbance, or disturbed ground or something like that in the description. Then the California Native Plant Society inventory of rare plants, we found 6 rare species that fit that category, and then 3 of those are known fire followers. And then the total number of locally rare plants, we found 58, which is pretty cool. And so, 27% of the species on Mount Diablo. So the top picture there, you can kind of see some of the fire followers there. The orange is actually fire poppy, which was probably the most talked about species in the post-fire hubbub after the Morgan fire. And then a little seedling of Calandrinia breweri, or brewer's red maids, which is an obligate fire follower, definitely something more you see in the coast ranges. There's a nice picture there, and it's pretty steep, actually. So here's the fire follower data. 17 species. The top left is this Antirrhinum, this little native snapdragon. It's got a seed that's about 1 millimeter across. And so that thing hadn't been seen on the mountain in 80 years. So, and if you imagine a seed that's a millimeter across surviving in the seed bank, it's pretty amazing. The dynamics of that species in particular was it seemed to increase in distribution and abundance in the second year compared to the first. So there's some lag time in germination triggers for that species. The most abundant species all over the mountain in terms of fire following was the bottom left, which is whispering bells. And that's a species that you see all over. I saw it at the Basin Complex in Big Sur. We saw it in the Rim Fire up in the Sierra and in a little, some patches. And we actually were up in the Rocky and the Jerusalem fires a couple months ago up in Lake County and saw it there. So that's probably one of the most common fire following plants in California. This Malacothrix, or the white daisy there in the top right, it's maybe a serpentine fire follower. It seemed way more abundant in the years after the fire than it had been on the landscape pre-fire on Mount Diablo. And then, of course, the fire poppy, as I mentioned, in the bottom right. Everybody was out trying to see the fire poppy, and it was only in a couple locations, but it was something else that also did seem to increase in abundance the second year after the fire. There's a nice picture of another fire follower there, the golden eardrops, which I've seen on Otay Mesa or Otay Mountain down in very far southern California, right near the border with Mexico, and a fire there a few years ago too. So that's a pretty wide-ranging fire follower in California.
So, graph time. So basically, we just looked at the different, and the first year, this is all from the first year, and really what we're just kind of initially looking at was just the difference between the different vegetation types. And as we expected, that fire following species, or the ones that we gave fire following distinction, came up mostly in Chaparral. Excuse me. As you can see from here, from these box plots, where the Chaparral and the Serpentine Chaparral had the most fire followers. We didn't expect to see many in grassland or deciduous oak, but one interesting thing is that we saw more, this both came out, bared out in the data, but also just our personal observation, we saw more fire-following species in live oak stands than we expected. And I think partly this could be due to live oak, its proximity to chaparral sometimes, but also there was at least one or two areas where the live oaks, probably due to soils, I'm guessing. We haven't really looked into it, but they're very, very short growing trees, and so they're kind of acting like chaparral. They have the same kind of burn mechanisms and burn cycles, and probably same soil heating stuff. So that was kind of an interesting thing to discover. But yeah, so chaparral has the most interesting fire followers.
Go back to the idea here of native disturbed, and just to pull out a couple examples, there's a mustard species, Calanthus, that is, you bump into fairly often out there in California, at least the Coast Ranges, but after the fire, it's all over the place, and also seemed to ramp up in the second and third year after. And then there's a lupin species that I had tried to find on the mountain for years and was unsuccessful, but after the fire, it seemed to be in a lot more abundance than I had previously noticed. So there's the Calanthus on the left, which was a pretty common thing in the plots in the chaparral, and the lupin, which was more of a grassland and blue oak woodland fire follower, and it's called big pod lupin, so you can see there that the pods are a lot larger than your typical lupinus bicolored dove lupin there.
So this shows, if we look at this graph, in our distinction between fire-following species and native disturbed, the idea would be that fire-following species need something from the fire to trigger their germination, so they're more obligate than these native disturbed species. Native disturbed species should kind of grow wherever there's some bare soil, basically. You find them on road cuts and stuff like that, but also in a fire. But given that, they should also grow in every vegetation type after a fire. And for the most part, that's what we're seeing here. And I'm looking forward to this winter, when we have a little more time, to look over these different species, and kind of this kind of data will really help us check is this really a native disturbed or is this a fire-following species? And as most of us know, these categories are somewhat synthetic. So, we have to do kind of a lot of research on these plants and kind of decide what their ecological niche or nature is. But anyway, but basically the data really did kind of bear out that like the native disturbed species were pretty equally found across different vegetation types.
Locally rare in the East Bay. So, yeah, a lot of work has been gone into tracking locally rare species for 25 years or more in the East Bay. So we have a lot of data. And of these species that we bumped into, there's a few that I wanted to point out here. And this little member of the carrot family on the top picture is Apiastrum that you'd barely see it at all in the chaparral on Mount Diablo. And when you did, it was a very diminutive plant, just a couple inches tall, wasn't very much branched. But after the fire, this thing was everywhere, and it was really big, like a small, clump about the size of a soccer ball. And so that was interesting to see, and it really demonstrated how far and wide these seed banks are dispersed in the chaparral across the mountain, that you wouldn't necessarily see them above ground in a non-fire environment. But you burn it, and the seed bank distribution is a lot bigger and more abundant than you had any idea of before. The same thing is true with this cryptantha here in the bottom right, little member of the Boraginaceae, closely related to popcorn flower. That's something that wasn't seen very often on the mountain, and it came up in a lot of places as well. And that was actually very abundant in the Basin Complex fire down in Big Sur, where it was actually a monoculture in some cases. And then there's some other things like this broom rape in the bottom left, which is a total parasite on chamise, that we're not sure whether or not it's, we saw more of it because the chaparral had been burned, and you wouldn't normally go crawling into the chaparral to try and find these things, or they really responded to the fire. One thing that definitely was true is that the geophytes, or the liliaceous things, the things with bulbs, really responded well after the fire. Like the calicortus, the mariposa lilies, everything the first year was just jumping out of the ground. It was unbelievable. And then the second year, it's like, they had basically exhausted all their energy that were stored in the bulbs, and the abundance of the bulbs was much reduced the second year after the fire.
So again, when we organize plants by locally rare and put them on here, we saw that most of the locally rare plants are coming up in the chaparral, and that's kind of no surprise because a lot of the locally rare plants are going to, in this study anyways, are going to be fire followers, and so that really makes you question, are the plants rare, or is the process of fire rare in chaparral in the Bay Area? And it's probably the latter. I mean, and some of these, and that's another thing we really want to tease out, is that are these locally rare or not seen very often, but after a fire they come up like crazy, and then so we're not really worried about them, that they're doing pretty good, or are they even rare within that small amount of time? So there's a few species that we saw maybe one or two of on this huge landscape, as opposed to the whispering bells, which was just everywhere. So anyway, so yeah, this just kind of shows the importance of chaparral, and I think it also illustrates, or one thing that we really try to explain to people is just that when you see chaparral, you have to think on this fire and this time scale, because there's a whole bunch of diversity going on in chaparral that is only seen after the fire for a short amount of time. And so the ecological process is kind of in that what might just look like a boring blanket of chamise to a lot of people actually holds a lot of ecological value. And there's a picture of year 2, right?
Yeah, so that's you can see the white tufts there hanging on the chamise. The second year, the vining morning glory just really took over and made it difficult to walk a little bit because we were tripping on that stuff all over. And so second year gets a little more cumbersome. The chamise obviously starting to take over quite a bit, and remember, between 2013 and 2014, we were still in a drought condition, a serious drought condition. But despite that, the regrowth really did take off just as much as you would expect in normal post-fire conditions. So things like chamise that have stored energy in the burls came back probably just as rapidly. The thing that we did kind of notice is that the seedlings in the second year that were maybe about an inch or two high didn't really survive, the chamise seedlings. So there was probably more die-off of chamise seedlings than would be in, say, a normal rainfall year. A quick summary of year 2, that if we just look at sort of species richness, we only lost 2. Fire followers, we lost 5, so there was you could start to see the decline. And so we went from 17, or let's see, what was it? I can't remember. I think it was 14 locally rare. We went down to 11. Native disturbed, we actually gained 2, so we'll have to look a little closer at that and see what the difference was, what the actual species that we were dealing with there. No change in the rare species on the CNPS inventory. Locally rare plants, we lost 8, which was also interesting, but we're still seeing, a pretty high percentage of the species found in Mount Diablo. It's just their abundance was definitely reduced. Year 3, kind of our expectations were met. Looking back at what Mary Bowerman had written in her Flora, we expected the California broom. It's a lotus species, formerly a lotus species, to start recolonizing the landscape. And that's really what happened, is that, whether it needs a couple years for its germination trigger to take effect after the fire, and then it just starts to come in after the first 2 years. We really don't understand why that is yet. It's going to take a little bit of research to look at the species dynamics there, but it was definitely one of the more abundant plant species in our plots on the 3rd year, and then a dramatic decrease in fire followers the 3rd year also, especially because the chamise just started to take over even more, and black sage in that case, and yerba santa, all these other common shrub species in the chaparral started to reclaim their dominance in the chaparral community. So squeezing out all the cool little annuals that are fighting for their days in the sun.
Yeah, so really, like I had mentioned too, I think that definitely in the future, we are planning to focus mostly on chaparral, because that was the most interesting with this methodology. And we kind of knew that going in, but like I said, we kind of felt interested and obligated to really give all the vegetation types a chance on Mount Diablo. So really we're interested in expanding this study design to different places in California that burn. And like I said, we really focused on developing something simple and efficient that can happen on anywhere in California and can be implemented very quickly. And we, I think Heath had said, I don't remember exactly when it was, but from the time we thought it would be cool to get up on Mount Diablo, and when we were out there actually sampling, probably wasn't more than 3 months. It was pretty quick, because already having everything and the whole method down and all that stuff, it could be even quicker in the future, So I think that's an important aspect of this. It's fairly simple. And really, I know both of us would love to be able to say things at more of the state level too about diversity. And so it's pretty cool. The data we got will be helpful to the park managers at Mount Diablo, and it's interesting there on in itself at the local level. But ideally, if more projects like this can happen across the state and more up into Northern California especially, we might be able to say some things at the statewide level, which would be very interesting. And also, that's part of building that database with relevant fire response and ecological information. So we'll have all the species in there, and as we just enter species into our database from our plots, there'll be all this ecological information attached to them, and so we can really kind of analyze the ecology and species assemblages from really kind of different angles and different facets. But that's pretty much our dream, is to be statewide.
And, this Mount Diablo study couldn't have been possible without our friends at State Parks who, like Brian said, we dreamt it up in October. We had funding support and a go-ahead by the beginning of 2014, and we were setting up our plots in February of 2014. Whereas we've been trying to work with BLM to get funding to do stuff on the lake and the Rocky and Jerusalem fires, and we've gone through 2 proposal rounds for grant funding, and did not win either, which in both cases actually it may not have mattered too much, because the funding cycles and the awards for those grants would have put us beyond the first season of sampling. So this is something that we keep bumping into, that the scientific urgency with getting into these post-fire environments doesn't match the budget cycles and the proposal cycles that we need to be able to do the work in the time frame that we'd like to. So that's something that we're hoping maybe we can find some other funding avenues to get this work done. But regardless, our interests are pretty intense, that we've been getting out and doing stuff on our own time. So we've been to the Rocky and the Jerusalem fires, and at least been doing some plant collecting and making some observations there, although they're not bound to plots and quads and are statistically significant. We have been trying to log those observations into our head, and so we're hoping at least maybe to try and do something for the second and third years up on Berryessa Snow Mountain National Monument, because we have a whole new national monument that there's really nothing, not that much known about. And if you can remember back to the slide that showed the yellow diamonds of where work has been done, this is definitely a hole in our knowledge of post-fire floristics in the North Coast ranges. And the Chaparral is just as interesting up there, and you have an interplay with the serpentine chaparral up there too, because there's huge serpentine bodies there that beg to be explored in a post-fire environment. But then we also, it's nice when you have a fire close to home. You just kind of become an ambulance chaser of fire followers. So last year there was a fire that burned in Tesla, or Corral Hollow. It was called the Tesla fire, but it was actually in the Carnegie Vehicular Recreation Area, which has been a hot topic lately, because they're talking about expanding into the Alameda Purchase, which is west of San Joaquin County into Alameda County. And we talked with the resource manager there, and actually let us get on after some negotiations to collect some fire data there. So we had, I think it was about 5 plots that we actually just established, because it was so close to home. We weren't concerned about getting funding, so we went out and did our belt transects out there, and a much different and interesting environment, because you're dealing more with sage scrub versus hard chaparral. And so although we were finding some similarities in post-fire following plants to Mount Diablo, it was really much different in other ways, where you see a lot more bush mallows and short-lived perennials than you do the annual species. So it's an interesting thing to look at, because you're much drier side, in sort of the rain shadow of the South Coast ranges. And so there's definitely some different climatic and species assemblages dynamics happening there. So I guess as far as the take home, tell your friends. We're looking for funding sources, and if you guys have any recommendations or ways that we can sort of take advantage of this, or change the dynamic of funding and fire, and trying to get these things started in the winter right after the fire season, we definitely would like to talk to you about it, because it's been a struggle. But otherwise, it's great fun, and get some good pictures out of it, and enjoy being out there. So thanks for listening, and that's all we have.